Hello my dear students, right now what we are seeing is a video of that particular building what we had taken. Most of the images and most of the videos whatever are added in this course belongs to this particular G+4 building. You can see all the slab, all the beam details written here, all the columns and all. Right now we'll see how the beam reinforcement has been arranged for this particular building. Okay, I'll take you to that video. Yeah. So right now we are in the ground floor and all these are the beam reinforcement what they've arranged it. So this is a very big, almost 8,000 square feet area of a slab centering and the beam reinforcement work what we are looking at. The entire area is 8,000 square feet. Yeah, so you can see this is my inside shuttering. Always remember, I want to tell one thing here. Let me add it here itself. Okay, see, let us say the depth of the beam, I'll write it here. Let us say this is this particular beam. Okay, the name of the beam is, let us say it is B35. I'm taking a random number, B35, and let us say the size is 230 by 450. Okay, so what is this 450? 450 is the depth of the beam. So when you do the shuttering, isn't it, when you do the shuttering, this is not 450 exactly, this is not 450. What we are supposed to do, you have a slab here, so this slab also will be having a thickness. Let us say this slab thickness is 150 mm here, and this is also 150 mm. So whenever you put this height, whatever is the thickness of your slab, that you have to deduct from the overall depth. That means what is the overall depth of this beam? The overall depth is 450 and minus what is the slab thickness. So here it is 150, here also usually it will be same throughout. Okay, we are not going to change 150 here, 200 here, that we are never going to do. We always try to keep it uniform. So 450 minus 150 you have to do. How much it is? 300 mm. Good. So this height what you can see, isn't it? This height what you can see, this is not 450. Even though the size of the beam was 450, when we put this shuttering, this is only 300 mm. Okay, and that remaining 150 mm, when you cast the slab concrete, that 150 mm will come along with the slab. So beam itself will be 150. Whenever we say the beam depth is 450, this is inclusive of your slab thickness. Always remember that. Okay, so that is why I told you I'll be explaining about this in the later part. I think this is the right time to explain that. Even same thing here also. If now I'll give you a small assignment, try to do. Let us consider, okay, this particular beam, I'm giving a size. Consider the name of the beam is B80 and let the size be 300 by 600 mm, and the slab thickness what I have here, I'll write it here for the slab thickness. Slab, yeah, take the slab thickness as 200 mm. Now tell me what is this height. When you put this shuttering, I want you to tell what should be this height. Quickly do a calculation and tell me what should be this height. Pause the video and try to do. I'll explain you how it has to be done. So what is the overall height? Overall height, it is mentioned, it is 300 is the breadth of this beam. This 300 is the breadth of the beam. Okay, and this 600 what you have, it is the depth of the beam. It's the overall depth. But when I put the shuttering, what I'm supposed to do, 600 is the overall depth minus what is the thickness of the slab? It is 200 minus 200. How much it comes out to be? 400 mm. So this height what I have, this height is 400 mm. The height of the shuttering is 400 mm. So where did that another 200 mm go? That 200 mm along with the slab when I do the casting of the slab, because beam and slabs are casted at once, so we call it as a monolithic casting. Then that around the remaining 200 mm will come along with the slab. Getting my point? So always remember that is how you have to do. Now I'll tell you one more thing, that is about the outside shuttering. For the outside shuttering I'll tell you how it has to be done. Yeah, now if you see here, you can see this is my outside shuttering. Why? Because you don't have a slab in this direction. So what will be this height? This height will be overall height. Let us say, okay, if I say, if this particular beam, let us say the name of the beam is B40, and if it is 230 by, I hope you are able to understand, it's not getting confusion, you're not getting confused. So it is 230 by 450. Let me redraw that. I'll write here. Okay, it is B40 and the size is 230 by 450. So since this is my outside shuttering, here what will happen, I'll do a shuttering of 450. Here I don't have to deduct anything. Okay, For the outside shuttering I don't have to do anything. This will be 450 only. Why? Because it's outside shuttering, you don't have any slab there. Getting my point? So that is why I told always for the outside shuttering you have to take overall depth, and for the inside shuttering it will be that is why you can see this this is at the greater height, isn't it? The outer shuttering is at the greater height. Yeah, you can see all the marking these people have done. See, I'm going to keep it here. Okay, I'm trying to adjust that. Similar, this will come here. Okay, this will come here, then this will come here, then this will come again, alternate. One hook is here, next hook is here, next hook is here, next hook is here, next hook is here. Got it? Yeah, I'll go a bit forward so you can see all the reinforcement have been arranged. Now I'll give you one task here so that it will be fun for us. Now I want to find how much stirrups I want in this particular beam. So we'll quickly do that calculation. Let us consider from this column outer to this up to here. Let us say the length is let us say the length is 5 meter. Okay, it is 5 meter, and this, okay, it's not visible, right? It is 5 meter. Okay, good. And let us say this stirrup what I'm supposed to place, I have to make use of a 8 mm stirrup. I'll write in this way, 8 dia stirrup. At you have to space at 150 center to center spacing. Now tell me, in the span of 5 meter, how many stirrups you have to place? Very simple calculation. What is the length? The length is 5 meter. I'll write it here. I'll write here. So 5 meter I'll put in terms of mm. 5000 divided by what is the spacing given? 150. Try to do it manually. I'll do it manually. You also can do it manually. So this will give me the total number of stirrup required, because as a site engineer you should be knowing all these things. You should be knowing how much stirrup is required and all. So I've given a small calculation. Do it. 5000, if I divide it by 150, I'm getting 33.33. so you can take this as 34. Always in the stirrup you have to add one extra. So I'm getting 33.33. we cannot give 33.33, which we can say 34. But always whenever we calculate the stirrup spacing and all, we have to add one extra to that, so it comes out to be 35. So I require 35 numbers of stirrups. 35 number stirrups is required. Got it? So you can see these people have kept a lot of stirrup here, right? So in this particular area, according to our calculation, I require 35 stirrups. So I'm going to keep 35 stirrups here. Getting my point? So that is how you have to do practically on the site. And then he is going to place wherever it is supposed to be placed. Okay, yeah. So I'm going a bit forward. So we have seen most of the things. Again you can see this is a very long beam what I have. They are given a support here in this way. They have placed everything. Yeah. And finally you can see these guys are placing the stirrup there. We already seen all these things, but still, yeah. And here it was mentioned a 20 diameter bar in the drawing. So similarly they are keeping a 20 diameter bar. How many bars are there in the bottom? 3 bars in the bottom. Similarly 3 bars in the top. And stirrup spacing might have been like 150 or 175. Based on that they are doing it. Again you can see these people are doing the binding of a stirrup. Yeah. Now these people are doing the cutting length. What is this cutting length? See, whatever rebar you have put here, isn't it? Whatever rebar you have put, you want to find what is the length of that. So practical on the side they'll measure it, what is the length, and then we'll be having this machine. With the help of this machine we'll try to cut the bar. Let us say I wanted a 10 meter length bar. So 10 meter, you'll keep it here and we are going to do the cutting of that. Yeah, you can see how they are trying to transfer the bar. You can see, no, so different people practice different way of putting the rebar. Okay, this is the second type what we are trying to see now. So here they are trying to put in this way. Okay, and then you have to pass it through this particular, because it's a continuous beam what we are putting up, so that is why this is what we need to practice. And you can see the drawing here, right? Whatever I was explaining, the same drawing these people are having, and I'm showing you from the same drawing. Yeah, so bottom 3 bars were required, so these people have passed 3 bars in the bottom, and then this will go and get lapped here. Okay, what is lapping and all we'll try to see. So finally you can see, no, everywhere the bar has been placed. Yeah, now we'll try to see how that L is given. That L bend we had seen, right? I told you we have to always do the L bend. So what they do is, whatever is the length required, they are going to do the marking on the side, and you can see this guy, I'll go a bit forward, they are going to do that marking. Okay, so that you can give a L bend to your rebar. So you can see this is a lever what we call. Okay, with the help of this we'll try to bend the bar, that L shape I want, isn't it? So in this way you will get that L, and this will go and sit on the other beam. You're getting my point? So that is how you have to do it. Yeah, I'll go a bit forward. Similarly, he has to do it for all the bars. So you can see here, no, how they have done it. You can see how this guy is doing it. Yeah, now we'll see how the extra bars will be given. See, you can see here, now these people are trying to pass the extra bars. See, top I wanted 2 bar, bottom I wanted 2 bar, we have done. Now again in the drawing they might have given an extra bar here. Okay, so you can see this guy is passing the extra bar now. I mean, it's a bottom extra bar what is trying to pass. Yeah, so go a bit forward. So where is this extra bar? Only up to this length. Okay, this extra bar is only up to that particular length. Now again, top extra also you have to provide extra bar. Now you can see here in the top also is providing an extra bar. So you can see here, no, this is your top extra bar what we have provided. Yeah, now you can see here. Now these are the your top in the middle portion you have to provide extra bar, like I mentioned. If you remember, from the column up to here you have to provide 5 feet, from here to here you have to provide 3 feet, right? Why is that so? Again, the same reason, because you'll be having a negative bending moment here. So if there is a negative bending moment, you want a top steel to resist that. So that is why you are given this top additional bars. Okay, if you remember the drawing, that is what we are trying to do it here. So you can see 2 bars they have given. Whatever was mentioned in the drawing, based on that they have done the execution. Yeah, they are trying to pass one more bar. Maybe 3 bars were written in the drawing, so that is why they have provided 3 bars there. Okay, so this also extra bar. Up to here we have stopped this 2 bar. This is extra bar, and the same way here also it is extra bar. You can see how many bars are there. Yeah, in this way we have provided the bars, and here it is a bottom curtailment bar what we have provided. Up here, from here to up to this distance only we have provided the bottom curtailment bar. So I'm trying to go a bit forward. So here also you can see, no, it's your top extra bar what we have provided. Yeah, so this is your secondary beams what we had. So it's trying to pass the rebar in this way. We have 2 bar at the top and 2 bar in the bottom. We'll try to put. So this is secondary beam, very simple, because this beam is resting on this beam and also on this beam. Both the ends are resting on the other 2 beams. So this becomes my secondary beam. So again you will pass the rebar in this way, then you are going to do the tying of that. Okay, and finally once all the beam reinforcement are ready, we have to lower down the beam. Now you can see practically how the lowering will be done. So all the beams whatever we were doing, so far everything is ready for this particular slab. Yeah, so you can see those people, okay, they are lowering the beams. You can see all the beams have gone down now. How they do that? See, this is how they try to do. I'll go a bit forward. Yeah, so whatever support and all you had given initially, right? So you have to try to remove that support. So this was the support what you had given. This guy is taking it out, this support, because the main intention of keeping a support was to hold all these rebars. Now all my rebars I have done. You can see how it has gone down. So in this way you have to pass all the rebars into this particular formwork. Again we'll go a bit forward. See, they are tied it here with the help of this pole, I mean with the help of this rebar. So I'll go a bit forward. So again they have done a lock. You can see this rebar they have kept. It's a kind of a lock. If you remove it, this bar will go down. Okay, yeah, that's how it is. You have to remove it, then it will go down. Yeah, we'll go a bit forward. Okay. Again you can see the lock here, right? So this lock you have to remove. Yeah. Yeah, finally a very small portion is left out, and we'll see that, and that's how all your beam reinforcement has to be lowered down, right? I hope you have got a complete idea. We have tried to see 2-3 different structures so that we don't have any doubts left. Now just by looking at the reinforcement, I feel you are in such a position to tell me that this is the top reinforcement, bottom the stirrup was this much and all. So that is the level of knowledge I wanted to convey to you with the help of these videos, so that we don't have any doubts left after this. So in this way almost all the beams we have done. Okay, how many beams are then? All the beams you have to follow the same thing. Yeah, here also you can see they are given that edge isn't the development length what I was speaking. From the top your bar has to get bent. They have done it here, and that is the right way of doing the work. Okay, so finally almost all things are done, only the few portion here it is left out. They will be doing all those things. Okay, yeah, so I hope you have enjoyed the lecture up to here, and we were able to understand most of the things with the help of these 2-3 different videos. So we'll see you back in the next lecture. Thank you.